explaining about static time analysis topics. In previous video, I explained some topics about the static time analysis. That video is I am making continue. Setup and hold timing. Setup timing. Setup timing is defined as a minimum amount of time data should be stable before the clock ends. Setup time is data should be stable before the clock ends. Consider it is a clock. Here is a clock edge. This is a clock edge. Total it is a clock edge. The setup for the setup time data should be prepared before this edge only. Then the setup is good. For the hold time is defined as the minimum amount of time data should be stable after the clock edge. For the hold, data should be captured after the clock edge. This is for the hold. So hold is good. If data is comes before means the data is come after the edge means setup is violated. If the data is comes before the edge, hold is violated. For the hold, data should comes before the edge means hold is violated. For the setup, the data is comes after the edge means setup is violated. It is about setup timing and setup and hold analysis. Setup analysis is first is a launch flip-flop and it is a capture flip-flop. The launch flip-flop will launch the data, the capture will capture the data. So it is starting flip-flop and it is ending flip-flop. Timing calculation between these two only. Now, setup slack. Setup slack is required time is greater than arrival time. Required time should be greater than arrival time. Then only the setup time will be meted. So setup time equation is RT minus AT. For the setup slack, RT required time minus arrival time. It is for setup. Arrival time what? Arrival time contains what? Arrival time T launch path, TCQ delay, T combination delay. T launch path was this one. From here to T launch path. TCQ delay is from here to here is a TCQ delay. T combination means from here to here is a combination delay. So here is a combination delay. So it is arrival time, required time. Required time is the total clock period plus capture clock path minus setup clock period. Here is a clock period, total capture clock path. What is the delay in this path it will take? So what is arrival time and what is required time? Arrival time, it will report the time taken by data to move from first flip-flop to the D pin of the other flip-flop. See here, date first pin of the D pin of the from here to here, D pin of the flip-flop. It is the one data required. After that, required time. It will report the time taken by data to move from start point of the flip-flop to the end point of the flip-flop. Means here to here is a required time. Total here, data start point of the end of the flip-flop to end endpoint. It is a starting flip-flop, it is an ending flip-flop. The data between these two, it is a required time. Arrival time is only launch part to the deep in of the other flip-flop. It is a arrival time. So setup slack is equal to T clock period plus capture clock path minus setup is greater than or equal to T launch path plus TCQ delay plus combination delay. This is setup. So setup minus. So it is a formula. So T clock period plus capture clock path minus setup minus T launch path plus capture delay, TCQ delay plus combination delay. It is for the setup like equation. So T clock period plus capture clock minus setup, what is the required time? See here, this is the required RD. So it total it is a RD, right? It is a 80. T launch path plus TCQ delay plus T combination delay is a 80 arrival time. So it is about the setup slack, hold slack. For the hold slack, arrival time should be greater than the required time. Arrival time what contains a T launch path, TCQ delay plus combination delay. Arrival time is contains. Required time is T clock period plus capture clock path plus hold. Is a required time. So it is the arrival time and it is a required. Same. What the setup is arrival time is contained. It will report the time taken by data to move from start point to the D pin of the flip flop. It is the arrival time. Means year to year. Arrival time, this one contains start point to the D pin of the flip flop. Required time is contains the start point to the flip flop to the clock pin of the flip flop here. From this flip flop, this is the required time. So T hold slack. So hold slack is combination of the arrival time is greater than required time. So launch path plus TCQ delay plus combination delay. So it is a required time. Arrival time is having launch path plus TCQ delay plus combination delay. Here to here is the arrival time. Required time is T clock period plus capture clock path plus hold is the required time here. Is the required time. T clock period plus capture clock path plus hold is the required time. So for the hold calculation, required time minus for hold calculation, arrival time minus required time. So arrival time is contains the T launch path plus TCQ delay plus combination delay greater than or equal to or clock period plus capture clock path plus hold. If the arrival time is greater than required time is, then the hold is good. If required time is greater than the arrival time, means setup is good. It is a setup and hold step. After that, timing report of the setup timing. We will say report. What is the report contains? So it is the report is first. It is divided into four parts. One is the header, data arrival, data required, and a slack. So what is a header? Header contains starting, means start point and end point. That which is a starting point and what is the ending point flip flop. Starting point flip flop, ending point flip flop. It will display like this. It is the flip flop. One is a starting flip flop is the ending flip flop. Path group is a CLK path group. Type is maximum. Maximum is for setup. Is a clock period. What is this incrementally starting to zero? It is starting zero. Increment path is zero. So clock network delay. Clock network delay propagated 1.10 to 1.10. It is incremented. 1.10 incremented. So here 0 plus 1.10 is 1.10. Clock path clock path plus uh, clock path in network delay is this one. Flip flop CLK delays 0.02 1.10 plus 0.02 1.10. So 1.10 to 0.50 is 1.60. So addition of it will take place. The total like this only 1.87 is the arrival time. Required time is clock period 4.0 to 4.0 and the clock network relay is 1.0, 5.0. So library setup is minus 2, 0.21. So addition of 5 point minus 0.21 is 4.79. So total 4.79 minus 1.87 is 2.92. It is a slack. If the required time is less than arrival time, the setup is violated. So here is a setup is metered. So required time is greater than arrival time. So header is contains that they contain the start point and the end point path rules which tells the timing path belongs. There are the part type. It is maximum which is states setup and minimum states hold. Data arrival time. It report the total time taken to arrive at the deep in of the flip flop. Means total time taken to data to reach deep in of the flip flop is the data arrival time. Data required time. It report the total time taken to arrive the clock pin of the first flip flop to the clock pin of the other flip flop. Means total time taken. to arrive from clock pin of the first flip-flop to the clock pin of the other flip. Total required time it is. Slack is a difference between the required time and the arrival time. So it is a slack. The slack only setup slack and hold slack it will come. What is the delay? The delay is defined as the time taken by signal to propagate through a cell or the net is a delay. Actual delay path is a sum of net delay and the cell delay is the actual delay. The cell delay is a function of input. What is the cell delay? Input resistance the output load. Intrinsic delay. Internal to the cell from input pin to the output pin caused by the internal capacitance. The total time for charging or discharging all the parasitic in a given net is a net delay. What is the uncertainty? It is defined as the difference between the arrival of a clock signal at the register in one clock domain and between the domains. This is the uncertainty. Uncertainties include skew, jitter, and the clock margin. Means combination. If uncertainty is a combination of skew, jitter, and the clock margin. What is the skew? Skew, I explained. Skew is difference between the clock source radius of the capture flip-flop and the clock source radius of a launch flip-flop. Jitter is clock latency is not same for every clock cycle. This I explained. It is one clock cycle. So again, next time is it is comes like this. Is a jitter. So it is jitter. In the previous video, I explained what is skew, what is jitter. In the setup timing, we will subtract the uncertainty at the required time. Uncertainty, what is the uncertainty value? We will subtract in the required time for the setup slack. It is a setup slack clock period plus capture clock path minus setup minus uncertainty greater than T launch path plus THQ delay plus combination delay. It is setup slack. It is RT. It is AT. So RT minus AT setup slack. We will subtract here uncertainty. So RT contains clock period plus capture clock path minus setup minus uncertainty. For a setup slack, AT contains T launch path plus TCQ delay plus T combination delay. So this is setup slack. Whole slack in the whole timing we will add the uncertainty at the required time. Here we will add the required time. It is a arrival time, is a required time. So it is a AT. AT arrival time minus required time. What is the required time? Plus uncertainty. So it is a whole slack. It's in the whole slack, required time is less, but we are giving uncertainty. We are making that required time is more. If the timing is needed or not, we are checking the whole slack. For the setup slack, required time should be greater, but we are giving the uncertainty. We are reducing the required time and checking if the timing is needed or not. It is the uncertainty we are giving for the setup slack and the whole slack. In the setup slack, we will subtract in the required time. For the whole slack, we will add in the required time. So it is. Thank you, everyone.